Hi friends, in this video we are solving a problem on method of variation of parameters. Okay, the given problem is y2 plus a square y is equal to secant ax. This is the first problem, and the second problem is y2 plus y is equal to secant x only. Next, y2 plus 4y is equal to secant 2x. y2 plus 9y is equal to secant 3x. Now you observe these four problems are similar only. So from the first problem, here you have y2 plus a square y is equal to secant ax. If you replace a is equal to 1, you will get the second problem. A is equal to 2 means third problem. A is equal to 3 means fourth problem. So I am going to solve the first problem. Later, if you are replaced a by 1, then you can do directly. If suppose they are given in the exam, solve y2 plus 4y is equal to secant 2x by the method of variation of parameters means just directly you do it. Okay, don't write a value and replace it by 2. To understand these problems, I am doing this one. Is it clear for everyone? Right. Now the given differential equation is y2 plus a square into y is equal to secant ax. So by the observation means this one you can write in operator form. If you written operator form, then this one d square plus a square into y is equal to secant ax. Okay friends, you observe this is the second order linear differential equation. So first we need to find out the complementary function in the step 1. So to find the complementary function, first we have to compare what we are doing here, method of variation of parameters. So in the method of variation of parameters, so the given differential equation is in this form: d square y by dx square plus p of x into dy by dx plus q of x into y is equal to r of x form. Here you observe friends, directly the given differential equation y2 quotient, that is nothing but d square y by dx square quotient is 1. So this is in the standard form only. So in the standard form, if you have to find the complementary function, this is in operator form, that is f of d into y is equal to r of x form. So the general solution of this is we will have complementary function plus particular integral. This is the general procedure. Now we need to find out the complementary function. Complementary function, how we will find out means, let r of x is equal to 0 first. So let y is equal to e power mx be a solution of f of d into y is equal to 0. Here we are taking r of x is equal to 0. Always to find the complementary function, we are not taking this r of x. So r of x we are treating as a 0. In earlier videos we have discussed this higher order linear differential equations. Same procedure we have to do. So you will get auxiliary equation f of m is equal to 0. So what you have, f of m is here m square plus a square into e power mx is equal to 0. So e power mx is never 0. Then you will have m square plus a square is equal to 0. This is the auxiliary equation or helping equation. So from this we will get the roots. The roots are here, m square is equal to minus a square, then m is equal to plus or minus ai we will have. So the roots are here imaginary, purely imaginary. So in this case the complementary function is equal to c1 e power ix we will write. So whenever complementary function having the imaginary or complex number, then we are writing directly c1 e power ax plus c2. One second friends, you see, if the given roots are in this form, a plus or minus bi form, then we are writing e power ax into c1 cos bx plus c2 sin bx. Now here you observe, compare with these two. Here you have a is equal to 0 and b is equal to I. If a is equal to 0, nothing but e power 0. E power 0 is 1. c1 cos, in place of b what I have? A. So c1 cos ax plus c2 sin ax. This is the complementary function. Okay. Now we have to find out the particular integral in the step 2. Step 2 particular integral means, from the complementary function, you see, we have to consider the particular integral as a into u of x plus b into v of x. What is u of x? U of x is nothing but this cos ax, C1 question. V of x is nothing but this sin ax. So now you see, u is equal to cos ax, v is equal to sin ax. Now what we need to find now? In place of c1 we are written a1, a of x, and in place of c2 we are written b of x. Okay, a and b are both functions of x only. So we need to find out this a value and b value. How you can find out means, we have a is equal to minus integral of v of x into r of x dx by w of x, and b is equal to you have integral of u of x into r of x by w of x into dx. Okay, so where w of x is equal to Wronskian. What is the Wronskian? You have u v, u dash v dash. So here you see friends, what is u? I have actually cos ax. This is cos ax. V is nothing but sin ax. What is the u dash? Cos derivative minus sin. Inside you have ax. So ax derivative is a and sin ax derivative is cos ax. Inside derivative a. So if you are simplified this, then you will have cos ax into cos ax is cos square ax. So a is there here. Minus of minus plus sin ax into sin ax is sin square ax. Here you have a. So overall a is a common. You will have cos square ax plus sin square ax is 1. So what is the Wronskian? A, which is not is equal to 0. Now we have a w of x also. You know what is v of x? C2 question. What is r of x? C1 question. What is w of x? A. So if you are substituted these three values in this, you will have a. Similarly, u of x value, r of x value and w of x value if you are substituted, then we will have b value. After that we have to substitute in ypa. Then you will get the general solution cf plus pi. Now we are solving a. Now minus integral of, what is the v of x? Here you have sin ax, and what is r? Secant ax divided by w of x. W of x we have a into dx. Now you see minus 1 by a I can write outside. 1 by a is there, I am writing outside. Numerator you have sin ax and into secant ax. Secant ax you can write as cos ax. Yes or no? 1 by cos ax. 1 by cos ax is nothing but sin ax by cos ax into dx. Now it is in the form of numerator. This is containing numerator and denominator. Whenever numerator and denominator is there, then you have to go for integral of f dash of x by f of x dx form. If the given differential equation is in this form, you see denominator is f of x, denominator derivative is f dash of x. If the denominator derivative in the numerator, then we will write log of f of x. That's it. Okay, log mod f of x we will write. Now you see what is the cos ax derivative? Minus sin ax into a. Is there in the numerator a? No, you don't have the numerator containing a and minus also. So you have to rearrange this. For that you see I am multiplying with a and divide with a. If I divide it with a, then I will have a square, and minus I am multiplying inside, minus I am writing inside, then a I multiplied, that is sin ax by cos ax dx. Now I have rearranged. You see, if you simplify this, a square and a getting cancelled, negative a is outside, then 1 by a is also there. So same. Okay. Now this is in the form of, if you consider this is f of x, cos ax derivative is minus sin ax into a. Yes, denominator derivative in the numerator. So what you can say? 1 by a square times of log of denominator. What is the denominator you have? Cos ax. That's it. So friends, here you won't get c. You have to remember, even this is in definite integral, because we got already in the complementary function arbitrary constant c1 and c2. This is indefinite integral. Generally in the indefinite integral we will let plus c, but in this method we are not writing, because already we have c1 and c2 are arbitrary constant in the complementary function. Right. Next we need to find out what? B of x. What is the B of x formula? You have B of x is equal to integral ur dx by w of x. So u of x is integral of, we have u of x is c1 quotient. What is the c1 quotient here? You have cos ax, and r of x is secant ax, and Wronskian is a. Okay, now you write on this all r, then we will have cos ax into r of x is secant ax, and w of x is you have a into dx. So friends, you see integral of cos ax is cos x. Secant ax you can write as a 1 by cos ax. So cos ax by x, 1 by a I am writing outside into dx. So these two are getting cancelled. Then 1 by a integral 1 dx. So 1 integration with respect to x is x. So you will get a x by a is the solution. Now which values you have? Capital A of x and capital B of x values you have. Then the particular integral is equal to, actually what you have? A of x into u of x plus b of x into v of x. Yes or no? So what is a of x? You have 1 by a square log of cos ax into, what is the u of x here? You have cos ax. U of x is cos ax. Okay, plus see here you have v of x. What is the v of x? X by a. And what is the v of x? V of x is sin ax. That is a C2 quotient we have, sin ax. So this is the particular integral. Now the general solution is y of x is equal to complementary function plus particular integral. Okay, the general solution we have complementary function plus particular integral. So we need to write a CF value and PI value. So here I have written CF and PI. So this is the solution for d square plus a square into y is equal to secant ax. This is the first problem. But the second problem, what they are given? d square plus 1 into y is equal to secant x they are given. Yes or no? So in place of a, what I have? A is equal to 1. If you are substituted a is equal to 1, then the general solution for d square plus 1 into y is equal to secant x, you will have c1 cos x plus c2 sin x 1 by a square. 1 by a square means 1 by 1. 1 by 1 means 1 only. Log of mod cos x. A means 1 into cos x. Okay. Plus x by a means x into sin a into x means x. So this is the general solution for d square plus 1 into secant x. So can you solve this problem if they are given directly? Same procedure, but don't write a. Next, another problem they are given. D square plus 4 into y is equal to secant 2x. Okay. So in place of a, what I have? 2. So put a is equal to 2 in the general solution. Then we will have y of x is equal to c1 cos 2x plus c2 sin 2x plus 1 by 4 times of log mod of cos 2x into cos x plus x by a. What is a? 2 into, this is 2x. 2x I have read into sin 2x. Is it clear? Next, third problem they are given. D square plus 9 into y is equal to secant 3x. So in place of a, what I have? 3. A is equal to 3. Replace a is equal to 3 in the general solution. Then we will have y of x is equal to c1 cos 3x plus c2 sin 3x plus 1 by a square means 1 by 9 log of mod cos 3x into cos 3x plus x by a means x by 3 sin 3x. So is it clear for everyone? Suppose if you replace a is equal to 4, then what you will have? D square plus 4 square means 16 into y is equal to secant 4x. You can do this one or not? So this is the method to solve the method and problem. Is it clear for everyone? In the variation of parameters, right? In the next video we will discuss just replaced by secant ax by cosecant ax, sin ax, tan ax, cos ax. All these we can do. Okay. In the next video I will solve those problems.